So the tree behind us here is a Tilia tomentosa petiolaris. That is a variety cultivated on a rootstock of the Tilia X Europea, and it has a particularly a bulbous graft. So, point of interest, we're going to have a closer look at it. I am aware that the tree has had some remedial work done in the past, and that's not pruning. The body language is largely explained here by the installation of the cable supports taking the load from that union. Should those cables not be installed in that crown, then the two stems would have more outward loading on them, and so possibly we'd see more of an ear or some sort of reactive growth on that union. The concern is what would happen if those cables now fail. The height at which the tree was grafted is quite clear. We can see the band there, and we see the growth potential of the rootstock was much less than the petiolaris variety that we have now. And above that union is another union. That's a tight fork with included bark, and it's evident there's some organic material in there as well, because there's a little bit of green foliage from an annual weed. The other side, I'm aware, having already looked, there's actually a elderberry bush growing out of it as well. So there is some concern of dysfunctional wood within that union, but also at the union of where the graft was. So here we are in the tree, and just turn you around. So how many cables are reasonable? Well, this tree has 7 in total. Some not complete, as they've previously failed. Now, I can see straight away that these bulldogs have been put on the wrong way round. You can see the curved metal bar is around the tensile line there, and they should be the other way round. That should be on the cut end of the rope. The eye bolt that goes right through the tree has been almost enveloped now, and the thimbles are still in place. And this one here the same, on the wrong way around. So if I follow that along to the other end, this wire has a bit of branch there, small twig resting on the wire. That should be cleared so there's nothing rubbing on the wire. And when we look at the other end again, let's see if I can just zoom in instead of heading over there, we can see again that the bulldogs are on the wrong way around again. Moving down the stem, there are obviously many cables in this tree. We can see another system. Now this was part of a triangulated system, wire running along. See some corrosion on that wire right the way to this end, and these bulldogs are on the correct way round. Lovely, and that eyelet has been completely enveloped with the tree. Looking the way back along here again, the clamps there, the bulldogs are on the correct way round, but if I zoom out you'll be able to see there's a problem. That wire's failed, so corrosion has got in there and corroded that one off. This was a triangular brace, so not allowing for any movement at all. Again, that clamps on the wrong way round, as is the other one, and as the other end of the broken wire as it's failed. And we can see below us from a bird's eye view the union that they perceived at the time was of significance. Now clearly this is now loading in a completely different way, because one of the 3 strands of wire, that triangle, are missing. As we look up the tree a bit further, we can see another wire in the distance up there, 7 in total in this tree, and the clamps on that one are on the correct way round. That wire right the way across here to one of my anchor points, or the stem that I'm anchoring into, just below that crossing branch there, and those wires, those bulldogs are on the correct way round. So back to this brace above me. This wasn't a triangular brace, there's just 2 strands coming off of this, so double the load on this stem. It's got that whole limb there which ventures up to about 70 feet. It's certainly about 50 feet, probably a bit, I'm over exaggerating that. It's probably about 40, 50, about 60 foot there of stem being supported by that wire. And then behind us the other one, and both another 40-foot stem carrying that whole crown. So these wires start at about a third of the height of the tree, and there are multiple wires to a height of just over halfway up the tree, and when these were installed they were likely to have been in the upper third of the canopy, but clearly the tree's not had any pruning works whatsoever, and as a result the cantilever is now excessive above these wires, putting more load on them. Just incidentally, there's another one hidden around that corner. I'll be able to show you both sides of that one from where I am. Just zoom in, have a look at those clamps. They are on the correct way round, enveloped completely, almost that eye on the tree. When I look at the other end there, it's almost as if they run out of wire on that one. Clamps very close together, but they are on the wrong way round. When we look at the other side of this, we can see how these eye bolts were installed, because you can just see there where the other end of the bolt is, and there's a bit of a washer on there spreading the load. The bigger the washer, the better to spread the load on that stem. So first impressions of the structure of the tree is that there is little decay, or there's little evidence of decay on these unions where the bolts have been placed through. So it's compartmentalised any ingress of pathogens at the time. Obviously the tree would have been somewhat younger, the stems would have been smaller when they were actually installed. The cables, well, they're obviously, looking at this one down here, they're in such a poor state that they are needing replacement. So if we look at this short cable here, it's coming from 2 leaders or co-dominant stems, and if we look down at what it's supporting, it doesn't look to be that significant a union, in that it's open and tensile in form, not tight in any way. Doesn't seem to be any defects at all, to be fair, with the stem. At the time of installation, bearing in mind that this cable may well have been installed in excess of 30 years ago, maybe there was another reason at the time, but that's not evident now, and so we won't comment any further about its suitability. The point is, it's now there, and should it be removed, would that union there now support that stem there? Well, there's a tonne and a half of material beyond that point, all being held by that cable. So the cables in this tree are wire. They are not dynamic in that they don't stretch. They do allow lateral movement, which is a consideration that needs assessing with how this tree has matured. But the suitability of replacing these wires with a textile component, which is a trend today, it's a lot easier to install when all's said and done. We can't put tension in them. When I get hold of that wire there's considerable tension in that wire holding that stem. In fact, I see movement in the whole crown when I do that, and it's not really going to be suitable to try and put a rope in there, because we can't lift those stems to be able to put sufficient tension in to put a direct replacement for that wire in there with textile rope. Now, should they have been put in with textiles originally, then they probably would have needed replacing before now, as perhaps these wires should have been, but they would have allowed for some dynamic stretching by installation of a shock absorber or an energy absorbing component, such as a rubber insert that goes in the middle of the rope. Well, multiple ones of these could be installed. And this is the triangular brace I was above a moment ago. Okay. When we install a triangular brace in this way, we don't allow for any dynamic movement whatsoever. It's very rigid. It doesn't allow for any lateral movement, sort of sideways swaying of the stem. So we can see clearly from this angle now that these wires have been installed incorrectly, with bulldog clips on the opposite way around to where there should be that round curved part of the bulldog should be on the cut end of the wire. On both of those, as an example, we can see if I pop it underneath. There we go. Okay. Now this one's failed. It looks to have failed directly as a result of that bulldog being on the wrong way around. The first strand's broken on that first clip. A alternative to installing a triangular brace like this is to install a ring in the center here. So if we popped a ring in the middle here, then we would then be able to bring from this point a wire to that central ring, and from over here all the way back again to that central ring, and from here again through to that central ring. In this way it would allow for more dynamic movement of the tree. That being said, it depends very much so on the nature of the defect and how much support is required. We wouldn't want to allow too much dynamic movement should the defect present the risk of a cupboard door failure.
There's a gap here of 10 centimetres where it's failed as a result of the bulldog clip being installed incorrectly. So this whole side of this tree is now being supported by one wire which is under a great deal of tension, so it's quite a concern. The morphology of the growth is now explained because of these cables being here and now not being here. So we can see some reactive growth as a result of this one failing. Thanks to the tree's been able to withstand the additional stress on the union down there and the stem, and that's go. When I look at this other cable that's still installed, the bulldog is again installed the wrong way round, and clearly some damage occurred to the wire, a little bit of slipping, likely during windy conditions where the tree is moving dynamically, and this triangular system does not allow for that. So we can see here the body language of this tree, and you can see the reactive group that's enveloping over this stem, clearly loading, swelling at separate ends to this one here. Hopefully the two may well graft. There's quite a tight union there, and it's all explained by the installation of the cable system taking the load from this area and supporting the leverage of the tree higher up. So as a result of the cables being so low, not at the optimum 2/3 height from this union to the top of the tree, the opposite loading works as a cantilever and is pushing this union apart. So this tree is not displaying reactive growth at this union that demonstrates it's actively supporting the crown above it. It is relying on the support system that's been installed in the crown above.